Hey guys, welcome to Conceptual Geometry, lesson 4.8. We are going to continue with rotations. What I'd like to do today is come up with a set of rules for 3 rotations. We're going to do that first by looking at a visual representation. So what I want to do is I want to make a sketch of the coordinate 3, 2. So on your paper right now, over on the side here, just make a small set of axes and plot the point 3, 2. Next, what I'd like you to do is take your paper and rotate it 90 degrees. Okay, now it should look like my screen here. What are the new coordinates of this point? Well, as you can see, now it's -2, +3. So let's rotate our paper around. I'm going to jot that down. -2, +3. So what I want you to do now is take a look at how this coordinate changed when I rotated it 90 degrees. Well, a couple things I'm noticing. The order changed, right? Here it's 3, 2, but here it's 2, 3. Not only did the order change, but I introduced a negative right here. So what would this rule look like if this became an XY? If this was XY, I'd have to change the order and negate the first one. So it would become -YX. And that is our rule for rotating 90 degrees. -YX. Okay, next what I want you to do, let's go back to this. Now I want you to rotate your paper 180 degrees. Or in other words, turn it upside down. So now it should look like my screen. What are the coordinates of the point? Well, now the coordinates are -3, -2. So let's rotate our paper back around, jot that coordinate down, -3, -2. So now what happened when I rotated 180 degrees is 3, 2 became -3, -2. I think this is a little easier to understand what we did. It looks like we just negated. We did not change the order, we just negated. So if this was XY, this point down here is -X, -Y. That's our rule for rotating 180. -X, -Y. Which, if you remember, is the same thing as a reflection about the origin. Okay, last one. Let's take this point now and rotate it 270. So basically what that's going to be is a 90 plus a 90 plus a 90. Okay, so now your paper should look like my screen. What are the new coordinates? Well, now it looks like it's 2, -3. Okay, let's spin our paper back around, jot that coordinate down. 2, -3. So what happened here? Again, this one's a little bit more challenging. 3, 2 became 2, -3. So I changed the order, and I negated the second one. So if this was XY, this one here is Y, -X. Okay, let's jot that down. Y, -X. And that's the rule for rotating 270 degrees. This last one's kind of silly. I won't be talking about it after today, really. There's no point in rotating 360 because you just get the original. So mainly we are going to be focusing on rotating 90, rotating 180, and rotating 270. All right, let's practice this example. I want to transform this coordinate, -3, 5, under the following rotations. Show the rule here. You don't really need to show the rule. I will just circle which one we're using from up above. All right, so for A, -3, 5 after a rotation of 90 degrees. So the rule here says -YX. So I need to change the order, and after I change the order, negate the first one. So 5 will go first, and I have to negate it. So that becomes a -5, and then the -3 goes over there. So the proper answer for this is -5, -3. Okay, next one, I have to rotate 270 degrees. So I look at my rule for rotating 270. This one says I change the order, yx, and I negate the second one. Okay, so if I change the order, this -3 goes here, and I would have to negate it. So it becomes a +3, and then 5 goes to the front position. So this becomes 5, 3. The next one, a rotation of 180 degrees, I think is the simplest because all we have to do is negate both. Don't change the order. So if I negate that, it becomes +3. If I negate that, it becomes -5. So this is just 3, -5. Now, these last two are interesting because it says -90, -270. So we have to think about this for a second. If I rotate -90 degrees, what is that equivalent to? So if you remember how these rotations work, we have a negative direction, we have a positive direction. So it turns out here that the combination of these two rotations has to be 360 degrees. This would be a negative rotation, which means this one here would be a positive rotation. To figure out the exact angle of that rotation, we just take 360 minus 90. Well, that's 270. So it turns out here that a -90 is the same as a positive 270. So there is no rule for -90, but what we just do is cross that out and write down 270. And since we've already done that here, you just have to copy that coordinate down. So that would be 5, 3. Likewise, you could probably figure it out. A -270. There's a -270 would be the same as a +90. So I'll just cross off this -270 and write 90 degrees there. And that's the same as rotating 90, which we already did up above. -5, -3. Okay, next example. It says if the letter F is rotated 180 degrees, which is the resulting figure. So here's how I would handle this. I would actually take my paper, write down the letter F, and then turn my paper upside down. So now what you notice is that my letter F has sort of become a backwards L, down and to the left. And then we actually have the other piece of the F there. So spin your paper back around to normal. Now, which of our four choices is down and to the left? Well, it's this one. All right, so that answer is choice B. Let's do the same thing with the next. It says if the letter A is rotated -90. So I will sketch the letter A and rotate my paper -90 degrees. Now you have to remember a -90 is rotating clockwise this way. So turn your paper a quarter turn that way. So now what I notice is that the A is pointing to the right. All right, so now I'll spin my paper back around and pick the choice that is pointing to the right. So again, that's choice B. The last example on this page, basically here it says the dotted triangle below is the result of rotating triangle ABC 180 degrees about point P. Using A prime for the image of A, B prime for B, and C prime for C, label the vertices of the image. So what they want to know is what coordinate is that, or what point is that? What point is this one? What point is that one? If we visualize this triangle ABC rotating 180 degrees, point A would rotate 180 degrees around point P, so it would end up right here. So that would be A prime. And that's all they want you to do. They want you to label those coordinates. So there's A prime. Okay, how about point B? Where would that go? 180 degrees around point P. We'll go right there. So that would be B prime. And then obviously this one over here would be C prime. Okay, next page. I'll just tell you right now, we are not going to do D. This becomes way too cluttered. So we will just do A, B, and C. Part A, we want to graph this triangle. A has coordinates -3, -3. So let's plot those. -3, -3, right there's A. B is negative 1, 5. B is negative 1, 5. So point B is right here. And C is 1, 3. C is 1, 3. There's C. All right, so what we want to do now is we want to connect those. Okay, now what am I doing with that triangle? Part B. I want to graph and state the coordinates of A prime, B prime, C prime, the image of triangle ABC after reflection in the line x equals 1. Well, to reflect in this line, we have to remember one thing. First of all, we need to sketch it. So what does that line look like? I remember this. The line x equals 1 crosses the x-axis at 1. So what type of line crosses the x-axis? This type of line crosses the x, crosses the x. So it's going to be a vertical line where x equals 1. So what I want you to do now is draw a dashed line right here. And that happens to be the line x equals 1. Now, to reflect these points, here's how it works. To reflect point A in this line, you have to count the number of spaces to the line and then go the same number of spaces to the other side. So A prime will go right there. Do the same thing for B. 1, 2, 1, 2. So B prime goes right here. Now what's interesting about C, since it's on the line of reflection, that would also be C prime. So now, let me just sketch in that triangle. And write the coordinates. All right, so let's start here. A prime looks like it's 5, negative 3. So we'll come up here. We're going to need this for part C. A prime is 5, negative 3. B prime is 3, 5. And C prime didn't move. It's the same as C, 1, 3. All right, well, this next example is what we just learned today. It says graph and state the coordinates of A double prime, B double prime, C double prime, which is the image of triangle A prime, B prime, C prime, after rotation about the origin of 90 degrees. So I want you to refer to the other page of notes. We have a rule for rotating 90 degrees. That rule was negative yx. So what we're going to do first is we are actually going to get the coordinates of A double prime, B double prime, C double prime first, then sketch it. It's too hard to visualize this and rotate your paper back and forth, especially when we have other diagrams on there. So first thing I need to be aware of, I'm starting with A prime, B prime, C prime. So I have two triangles here that I could use. The original, ABC, and the one I just got, A prime, B prime, C prime. Well, I'm starting with this one. So what I need to do now is I need to apply this rule to all three of these coordinates. So to get my coordinate for A double prime, I have to change the order and negate the first one of this. Well, what do I get? Change the order, negate the first one, that becomes 3, 5. Now apply that rule to this one. Change the order, and then negate the first one. That becomes negative 5, 3. And then do the same thing here. Change the order, negate the first one, negative 3, 1. So now all that's left to do is plot these points and sketch in that triangle. Okay, so A double prime is 3, 5. Well, if you notice here, it's kind of interesting. 3, 5 is the same as B prime. So I have to label this with 2 letters. That's also A double prime. B double prime is negative 5, 3. So negative 5, 3 is this point right here. And C double prime is negative 3, 1. There's C double prime. And then we sketch that in. Now, when we're done, I know this is kind of challenging, but when we're done, obviously all three of these triangles should be the exact same size and shape. And number two, this one might be harder for you guys to visualize, but here maybe it's a little bit easier with the different colors. Basically what we did is we took this triangle, rotated it 90 degrees, and it became this triangle. So that might be a little bit easier here with that illustration. A prime rotated up here to A double prime. B prime rotated here to B double prime. And C prime rotated there to C double prime. Okay, guys, that concludes day 8 notes. So now you can go ahead and do the homework worksheet. Please reach out if you have any questions. Thanks for watching.